We are in the UK. I promise that I'll do within the 5 minutes.
Okay.
It's yours. All right.
Yes, all good.
Excellent. So welcome everyone. I'm Jenks. I'm the CEO of SmartKem. Before we start, my lawyers require me to make a public markets disclosure. Feel free to read it at your leisure. SmartKem is a supplier of organic semiconductor materials used to make arrays of transistors using low temperature solution coating processes. Materials have strong IP. We've also developed EDA tools to allow customers to design and simulate their circuits. And we can manufacture prototypes at our facilities in the United Kingdom. We're targeting the display industry. I was recently speaking at the SID conference in San Jose, and I was struck by two things. Firstly, while everyone was showing off their absolutely fabulous OLED, quantum dot, and micro LED displays, liquid crystal displays are still the market leader, 3 times the size of everything else. And that's because the CapEx investment required to make the transistor arrays to drive LCDs is a fraction of the CapEx investment required to make transistor arrays to drive OLED displays. For most applications, good enough visual performance at the lowest cost continues to win. And secondly, in addition to the usual promotional talk by the display manufacturers, the originators of the Metaverse, Google, Meta, etc., were also there, and I've not seen that before. What they said was, and I paraphrase, there is no solution available, large or small, at a low enough cost to enable the ubiquitous adoption of the Metaverse. And that's really important because 80% of communication is visual. All displays have 2 things in common: a transistor array providing power and control, that's amorphous silicon for LCDs, IXO or LTPS for OLEDs, and even PCBs for outdoor signage. And they have an electro-optic layer for providing the image. To drive costs down to a point where they intersect the needs of the Metaverse, you have to use manufacturing technologies that require lower manufacturing CapEx investment and consume less energy. That means low temperature solution coating processes, printing. The electro-optic layer to do that exists, or there's a roadmap to their deployment with OLEDs and quantum dots. And what SmartKem is bringing to the market is the other half, the transistor array. We've developed TRUFLEX organic semiconductors formulated as inks that are processed at 80 degrees, not hundreds of degrees, and have been designed to be compatible with equipment used to make amorphous silicon arrays, except that you don't need to use the high energy, high temperature, high CapEx parts of those lines. Our ability to process at low temperature also means we can use a range of low-cost plastic substrates, not expensive glass or polyamides. And just in case you thought it was easy, it's not just one layer of semiconductor, it's a full stack of materials and the processing parameters used to make those transistors. And that's required $50 million and taken more than 10 years. We've got joint development agreements with Right Display in Taiwan to make OLED displays, Nanosys to make quantum dot displays, and as of last week, an unnamed Taiwanese partner to make mini LED displays. So within 5 minutes, that's us, SmartKem, supplier of organic semiconductor materials used to make a new class of displays that we believe will be needed to enable the Metaverse. Thank you.
Thank you very much. Thank you for joining us, and thank you for sharing about your very interesting technology. I'm really, really delighted to see sort of organic TFT technology becoming so mature.